Thanks, Professor Lau. Oh, why am I speaking in English? Do you guys know why? Because our first presenting school, Diocesan Girls School, will talk about what are the factors that affect the air quality in Jordan. Sounds interesting, right? Let's welcome them and give them a round of applause.
Good afternoon, everyone. We are the representatives from Diocesan Girls School. I am Lauren, and this is Teresa. This is our second year taking part in the project Community Explore. Today, we are going to share our findings about the air quality around our school from the past year. Some background information for you to know. Our school is located next to three main roads and bridges, namely the Jordan Road, Gascoigne Road, and West Kowloon Corridor. The nearest stations to our school are Mongkok Roadside Station and the Sam Shui Po General Station.
Last year, we focused on research on comparing the results we obtained from that of the roadside and the general station. In addition, we compared the results on the amount of samples collected. This year, we focus more on the individual results of each variable, and from that, we deduce a few conclusions. Moreover, this year, we carry out the experiments at two different locations, in our laboratory and at our school gate. Our lab is located above a field, opposite to some residential flats, hotels, and restaurants, and faces a relatively narrow and less busy street, while our school gate faces a very busy Jordan Road.
To record the amount of NO2 in the air, we soaked a piece of filter paper in TEA solution and collected the NO2 through a pump. Then we soaked the filter paper in water, and after a while, we mixed it with the A and B dye so we can measure the amount using the photometer. Similarly, for O3, we used the KI solution instead of the filter paper. Then we mix it with the starch solution to measure the amount with a photometer. For black carbon, we collected the suspended particles on the filter paper and scanned it to collect the RGB values.
Generally, we noticed that the amount of NO2 collected at our school gate is higher than that of the lab. The highest data we collected at the school gate is 124.6 ppb, and the lowest is 46.1 ppb. In the lab, the highest data we collected is 110.4 ppb, and the lowest is 25 ppb. We didn't find much relationship between the NO2 concentration and the temperature, so we focused on the location. The results show that the NO2 concentration data collected at the school gate, which is the blue line, is usually higher. This is because the number of vehicles passing by the school gate on Jordan Road is high. There are many traffic jams at our site, which contributed to a relatively high NO2 concentration measured at the gate. For example, on the 9th of September, the leftmost data on the graph. The data measured at our school is particularly high, at 265.10 ppb. We got our chemicals on that day, so it could not be the chemicals aging. We checked the news on that day, and we found that at 4 p.m., which was when the time we collected our measurements, there was a traffic accident at Wuhu Street, near Chatham Road North, which caused traffic congestion from our school to Tsim Sha Tsui direction. Let's take a look at another example. On the 18th of September, the NO2 measured was 130.6. On the same day, the fast lane at Valley Road had a traffic accident at around 3:30 in the afternoon. Cars passing by DGS to Tsim Sha Tsui direction suffers in traffic jam. At times of traffic congestion, the amount of NO2 skyrockets because when the engine is not continuously switched on, the temperature is not high enough, leading to incomplete combustion, contributing to higher concentration of NO2 measured. These are only some of the examples of traffic jam at our school which are most representative. In general, traffic congestion is serious and occurs very often in the area, which explains the relatively high concentration of NO2 measured at the gate. The NO2 concentration data collected at the lab, which is the red line, is relatively lower.
Even though the lab also faces a busy road at 25 meters, it is around restaurants on the road is less likely to reach the lab, while the field acts like a barrier and distances our lab from the road. NO2 is diffused upstairs. Therefore, the concentration of NO2 is lower. We can conclude that the NO2 concentration is related to the amount of vehicle emissions, and hence the location. However, we have also noticed some fluctuation in our data. Sometimes, the NO2 concentration recorded at the lab doesn't follow the usual trend. We couldn't find the relationship between the amount and the temperature nor the vehicle emissions here as well. So we decided to look at some environmental features. We found a fence from a nearby hotel that faces our lab. We usually collect data on Thursdays and Fridays, when this restaurant is open, which means the fence is actively giving up some pollutants. Typically, vents from commercial buildings give us some NO2 due to food processing and gas cookers. This fence is facing directly where we put our filter paper and is trapped by tall buildings of our school and nearby residential flats, resulting in less efficient ventilation. Although it opens daily, the amount of food processed may vary. We think that this can also be a factor contributing to the irregular data collected at the lab.
Moving on to ozone, we compared our data collected at the school gate and lab. Like we did for NO2, the highest data we collected at the lab is 42.66 ppb, and the lowest data we collected is 9.64 ppb. At the school gate, the highest data we collected is 75.9 ppb, and the lowest is 4.81 ppb. The blue line is the data collected at the school gate, while the red line is the data collected at the lab. We have noticed that most of the data collected at the school gate, while the red line is, we have noticed that most of the time, the ozone concentration at the lab is higher than that at the school gate. To take a closer look into ozone, since our lab is located at a certain height, it is regarded as stratospheric ozone. The amount of sunlight, which is key to forming ozone, contributes more to than other factors. Outside our lab, there is an outdoor field which sunlight is ample. This can explain the relatively higher ozone concentration. We also collected samples at the school gate, which is located at ground level, and the type of ozone is tropospheric. Unlike stratospheric ozone, many more factors can contribute to its concentration, such as emissions from cars and sunlight. Although there are many vehicles that could produce a lot of NO2 and emissions, the ozone concentration at the school gate is relatively lower, as there are a lot of trees planted there. That region is more shaded and affects formation of ozone in that area, which can explain the lower ozone concentration. Apart from the above, we have also noticed a positive relationship between the temperature, NO2 concentration, and the ozone concentration.
Ozone is formed through a series of photochemical reactions that involve sunlight and heat. It can also be formed from oxides of nitrogen. Take the 24th of March as an example. The temperature that day was 23.1 degrees Celsius, which was relatively high compared to the rest of the week. It was a sunny day, and the NO2 concentration was 82.5 ppb, which was also high. Hence, the ozone concentration was also high, at 42.66 ppb. The high temperature, alongside ample sunlight and high NO2 concentration, leads to a higher ozone concentration. The concentration of NO2 must be high due to the large amount of vehicle emission, but because of the location of a shaded area, the ozone concentration isn't very high. Finally, we are going to share our findings on the amount of black carbon collected. Black carbon is produced by incomplete combustion of fossil fuels and biomass. It is emitted from various sources including diesel cars and trucks, residential stoves, etc. We would like to find outage factors that are affecting our results. Similar to NO2 concentration, the amount of black carbon collected at a school gate is usually higher than that at the lab. This is also because of the amount of vehicle emissions, specifically diesel engine emissions, which is the major factor of the formation of black carbon.
As for the data collected at the lab, the concentration of black carbon is relatively low. Although residential stoves should increase the concentration of black carbon, and the fans from the restaurant is likely to increase the concentration of black carbon remains low. We could deduce that the pollutants from the fans has a low impact on the formation of black carbon, probably because of the little amount compared to that of the vehicle at Jordan Road. Hence, conclude that the large amount of vehicle emission is the biggest factor to our concentration of black carbon. Moreover, we noticed that on the days with higher black carbon concentration, the temperature was higher. For example, on the 5th of May, the temperature was 27 degrees Celsius. Black carbon absorbs sunlight strongly, which causes the high temperature. This reflects the positive relation between the two. To sum up, this year, we have compared the concentration of each of the variables of different locations. The amount of NO2 and black carbon is affected by the location and the amount of vehicle emissions. The amount of ozone is affected by the amount of sunlight, temperature, and NO2 concentration. For black carbon, vehicle emission affects its concentration most.
Next year, we would like to further look into the possible factors, such as finding more about the relationship between black carbon and the amounts of diesel vehicles, conduct the experiments at more locations, and consider new factors like time and humidity and wind direction. This is the end of our presentation. Thank you.
Thanks for the great work done by the girls. It's a really detailed analysis of the of the environment. Is there any question from the audience? If no, we will continue.